Good morning and welcome to today's webinar. I'm Patrick Williams with Greenhouse Management Magazine, and I'll be your moderator for today's webinar titled Designing Your Irrigation System, presented by Dramm Corporation. This is the first of 3 webinars in Dramm's Everything Water webinar series. Proper irrigation is vital to the success of any crop. Whether hand watering or automating the process, the proper tools and design make a big difference. In this webinar, Dramm, the leader in water, will discuss what you need to consider when designing your next irrigation system. From flow considerations to must-include components, Dramm will cover the entire design and flow process. If you have any questions, you can put them in the questions box. Our presenter today is Kurt Becker, EVP of Dramm Corporation. Kurt is also the Commercial Products Manager for Dramm. He has spent the last 23 years working with growers on improving plant health, including advising on irrigation systems and management. Kurt, we're really glad to have you here today, and feel free to get started.
Thank you very much, Patrick. Thank you all for joining our webinar today. We started thinking about doing these things as a way to get some education out there about some topics that there's a lot of experience in the industry, but there's not always necessarily all the full practical experience. And we wanted to start this series to start to explore those things, go a little bit more in depth. Dramm, as a company, has been around for a little bit over 75 years. We celebrated our 75th anniversary a year and a half ago. Now we've been in business for 77 years, and it all started with what you see on the front of that image, the face of a water breaker. Our aluminum water breaker, the 400 AL, still one of the more common tools out there. That was meant to help people water plants. It was breaking down the water, more simulated rain type setup. You were getting very even droplets that were broken down so that you didn't disturb the soil. We started working with water back then. Since then, we've branched out to dozens of different nozzles, valves, and other ways to hand water. But we recognized that some of the labor was still an issue there. Hand watering is never going to go away. There's still good reasons why you may want to do it, but a lot of watering can be done through more of an automated process, whether we're going to be doing drip irrigation, overhead, misting. We moved into that probably 45, 50 years ago, and we've been pushing further and further on that ever since. From there, we moved into spray equipment, which is just another way to move water. We're just creating finer droplets. We may be including pesticides or plant growth regulators or things like that in that water, but it's still about putting water onto plants. We also moved into horizontal airflow, which you may not think moves water, but it actually is very important at evening humidity in a greenhouse. We actually got involved in it because of the spray equipment. We found that some of our automated spray equipment or foggers, we weren't distributing the fog properly either without HAF or with poorly designed or poorly developed HAF systems. So we got into it mainly because we were trying to move that moisture around. And finally, one of the newest segments that we've really started has been a water treatment and management division called Dramm Water. And that's really the main reason we put this series together, is we wanted to showcase all of our water capabilities and get people thinking about some things beyond just day-to-day watering of plants. Start thinking about how they're going to manage their water in the future. We all know that water is becoming more and more scarce. We're seeing drought conditions. We're seeing contamination of lakes and streams. And with that, there's more and more push and pressure on our industry to be better stewards of that water. Even states where water is not scarce, we're seeing every well being metered. We're seeing them just trying to monitor how much water is being used. And so we wanted to spend some time in the next 3 different sessions talking about those issues. Today we're going to talk about the point source, though, putting water on the plant rather than moving it around. As I said, we've got about 50 years of experience focusing on irrigation. So today, that's what we're going to be talking about, designing your irrigation system. As Patrick mentioned, we have 2 other webinars in the series that'll happen in the next couple months. The second one is going to be a month from now, talking about filtration. We're going to be talking about the basics of it all the way up to advanced filtration. But filtration, is one of those things that we find is very often underused, which really affects when we're putting an irrigation system together. If it's not filtered well, we see problems we see problems when we try and deliver the water to the plant. And then the third in the series is going to focus on complete water treatment and management systems. We want to look at your source water. We want to look at where the water is going if it leaves the property. If it's not leaving the property, how are we treating it? How are we making sure that it's safe to be reused? We've worked with a number of growers over the past 8 years of that new business segment, really on complete water plans and talking about, maybe not necessarily a system you're putting in place today, but something you're going to have, building a plan for the next 10 years as far as as your businesses grow and as water becomes more and more of a concern. How are we planning for that and putting together a step-by-step, okay, we're starting here, but we want to end up there. And that'll be more covered in the third topic. As I said, we are going to focus on designing your irrigation system. There's a number of things that I really want to cover today, starting with your source, the flow from that source and the pressure from that source. The source, we're going to cover, how to deal with different sources more in some of the other webinars, but we need to know where your water's coming from, and we need to know how much there is, and we need to know what kind of pressure it is before we can design a watering system for you. We are going to talk about different components that many growers sometimes leave out of systems. They're very basic components. They don't add a lot of cost, and the value of them really comes in, down the line as you're maintaining a system, as you're working with your system in the future. Those components are important. We're going to talk about supporting your system. We see a lot of greenhouses where systems are sagging and not in the greatest shape. Thinking about that up front is an important thing to be considering when you're putting together an irrigation system. Talk about some basics of installation. We're mainly dealing with PVC. There's some simple tools and techniques that we want to make sure you guys are aware of that are going to increase the longevity of your system and make maybe putting it together a little bit easier. We are going to talk about how you control your system. There's a lot of different options available for that. We want to make sure that you consider them and maybe think about more of the automation side, even if you don't fully automate. Having it installed is not a bad thing for the times when you might need it. And then finally, designing it, putting it all together into a package and making it fit and work together. When we talk about source, flow, and pressure, they're all related. We want to know if it's coming from a well, coming from a pond or surface water, river or stream. We want to know if it's coming from the city. That all enters more into the chemistry of your water more than anything else, but it doesn't. So the other two webinars that we're going to talk about, filtration is going to be important with some of those more than others. Altering the chemistry of your water is going to be more important with some of those sources than others. But all of those things are important as we're designing a system. Are we coming from a well? What is the pressure that comes off of that well? What is the flow capacity that comes off of that well? When we work with a lot of growers, we find very often that the growers aren't always aware of what their flows are. Quite often we see that people aren't necessarily understanding of the difference between flow and pressure. We hear very often that someone will say, oh, I don't have enough pressure to run that. But really what it means is they don't have enough flow to feed the system that they had installed. We look at these things because it's very important when we start breaking down how we're going to zone up the system. Do we have enough capacity for a certain nozzle in an area? Maybe we don't. Maybe we have to break a zone into smaller zones to be able to use the amount of water we need to do a job. And one of the things, when we very commonly we're called into someone has a system that they've got installed and they're not happy with its performance. It's someone else's, or it's maybe even one of ours, but they want some help, putting in something different, a different nozzle. And when we go on site, we look and see that, the nozzle that's there is probably appropriate for what they're doing, whether it's ours or somebody else's. But what we found is that they've got 10 nozzles at a gallon a minute apiece on a system that can only supply 5 gallons a minute. And so when you only have 5 gallons a minute coming in, most people think of that as a pressure problem because the nozzles don't spray the way they should. And really what it is we're not providing enough flow. We may have 50 psi behind it, but if we're putting it into a system that needs 10 gallons a minute, the flow isn't there to fill that system and keep the pressure up, which then means that the nozzles don't spray properly. So a lot of times, we need to look at flow from a standpoint of how we're going to zone the systems up to make them actually operate properly, depending on, and all that goes back to what we're going to water. We need less water to mist plants and cutting the seedlings than we do when we're watering 2-gallon containers. We need more water when there's more volume of media to wet. So we look at what you're going to water, and then we look at how much water you have available, and that's going to help us determine how much how we design the system. We've got a very simple chart. This is actually available on our website. It's available in a white paper we have on our website. It is very rudimentary. It is very generic. Pressures can alter this slightly, but the point of showing this chart is that if quite often a grower will just tell us, well, I got a 3/4 inch pipe coming into that greenhouse. Assuming that you have enough water behind that 3/4 inch pipe, we can probably get about 12 gallons a minute. We generally don't want to exceed that. We probably get 13 or 14, but realistically, we like to say we're going to get about 12 gallons a minute out of that. And then we would design a system based on that. We would say, okay, if we've got 12 gallons a minute coming into the greenhouse and we need 20 to do the job, we're going to need to make 2 zones out of that greenhouse to be able to water that appropriately. So a chart like this really is going to help you figure out as you're looking at, the system and trying to start from design. We always start at flow, and we'll always start at what the demand is going to be, how much water we're going to need, what the flow is, and then we can start figuring out what goes in from there. When we're putting together a system, there are really 3 components, actually 4 if we break that last one down into 2 different pieces, that we consider important to every system. The first one on the left is a filter, a little Y filter. Now, as I said, we're going to have a whole seminar, or a whole webinar on filtration next month. That's not meant to cover this little one. This little guy is part of an irrigation design system. This is not part of your entire system filtration. This is filtration for the zone. And we recommend a zone filter at every zone. And we recommend that because over time, you're going to grow biofilm, algae, gunk in your lines. You are going to have, when you first set up a system, you're going to have PVC shavings and grit and things from, that pipe sitting in the yard for, 3 months as you're getting ready. That filter is going to protect what's behind it. Generally, for most of the types of systems we're working with, 150 mesh is about the standard size that we would need. They're very easy to clean. They have a flush to remove out large debris, but you just unscrew that cap and you can, clean the screen a little bit more vigorously. That's going to protect your investment behind it. And more importantly, when I say investment, I don't only mean the irrigation system. I mean the plants on it. If I've got 100 drippers on a line and 5 of those are clogged, meaning that those plants don't get watered, your plants are the investment there, your crop. So we want to make sure that we're providing water to all those plants, and we do that by making sure that the irrigation system's integrity is intact. We do that by making sure we filter out any junk that's going to get caught in those types of systems. Next thing you see there is a pressure regulator. You don't always need these. Really, it depends on what your pressure is coming into the greenhouse that you're going to be working with. But a pressure regulator is a really good tool to make sure that we're not exceeding any pressure limits for any of the nozzles, drippers that are in place. A lot of people don't necessarily recognize it, but most drippers have a minimum and a maximum pressure. You run them too high, and they stop compensating. So their flow rate alters between them. Most of them are meant for a specific range because what happens is that there's a diaphragm on the inside that you're pushing away from an opening, which allows the water into the check valve or into the body of the dripper, the emitter. It goes around that diaphragm coming out the outside, the exit. Well, the more pressure you exert on the inlet, the more you actually press on the outlet. If we put too much in, we can actually shut a dripper off. It's possible with some emitters to shut the flow off with too much water, too much pressure. So pressure regulators, very simple component. They're made in a variety of different pressure ranges. We want to make sure that you're keeping things, keeping the pressure even, and we're not overpressuring anything. And finally, probably the most important piece up there that I consider is a hand valve and a union. Normally, I like to include them in one piece, although you can buy unions separately from hand valves. But really what that piece is, other than it is a maintenance tool. So if I put that in front of the filter, it allows me to very easily open up that filter and clean it out. If I don't put one in front of that filter and I take the filter body off, what I end up doing is getting really wet because I've either got to go back somewhere further to where I can actually shut the water off to deal with that filter. You're going to have things like solenoid valves. You're going to have that pressure regulator. You're going to have other things in here that are going to require some type of maintenance or possibly replacement over time. That combination union and ball valve allows me to, one, turn off the flow so I don't have to drain the system back to the next valve in line, which generally takes time and stops watering for a longer period of time. But then I have a union that I can simply unthread that cap and remove those components because they're generally threaded. There's kind of a way you want to put these things into place. You'd put a ball valve, you'd put a filter next, because we want to protect anything that comes after it. So that's going to be a pressure regulator. We want to protect the pressure regulator from grit and debris. We're going to protect the solenoid valve that comes from grit and debris. Anything gets into that diaphragm of a solenoid valve and it leaks. But having that union there allows us to unthread it, simply unthread those components, put in new ones, retape them, stick them back in place, drop the union back in place, thread it down, and you're back in business. If you don't do that, you end up getting a hacksaw out because you've got a glued fitting in there and you've got to cut that piece. And now you got to go to this plumbing supply store, the hardware store, go buy some couplers and things like that, extra little piece of PVC to kind of make up the distance. Ends up taking a half a day and stopping you from watering during that time. So these components we consider incredibly important. We put them in any design that we do, and we would encourage you to include them when you are designing your own systems. When I talk about supporting your systems, I say that because in greenhouses, we're really not using some of the typical residential type components that we would use in like building a house or something like that. Copper is not something that we normally use for watering systems. Makes it a lot easier. PVC is a lot easier to work with. It's glue, not having to, sweat copper, solder, and flux and work with, torches and things like that. But it's not as rigid either. PVC can sag. PVC is plastic. It's softer. The fact that you can cut it easily makes it it sags. When someone typically puts in a piece of PVC into a greenhouse, it looks nice and rigid and straight. That's typically going to remain that way when we're using distribution lines or stuff where we actually are supporting it to a wall, we're supporting it to parts of the structure where there's not as much distance between them, so end walls, things like that. Where we start to see more of a problem is when we start trying to cross a span. We're crossing a 12-foot post spacing from truss to truss. That 12 feet, without anything there to actually help support the structure, we get a little bit of heat, we get some sunlight in the greenhouse, we start, we have water, the weight of that water inside there, and we start to see PVC doing this, starting to sag a bit. So you need to think about how you're going to support that. One of the things that commonly people will do is you'll stretch a tension wire and put some hangers and things like that on there if you can. Using raceway or support is great. So again, for distribution line, it's pretty easy. But when we start using PVC more as a component in irrigation lines and the laterals where we're crossing those structural spaces that are a little bit bigger, it's harder to do that. So, one of the things that we've actually come up with a solution that we call Polyrail, which is available in a couple sizes, and it's a rigid aluminum construction, which is not watertight. It's just meant to house PE tubing. So we take the polyethylene tubing, we snap it in through the opening in this stuff, and then we can basically hang it at 12-foot sections without any issues because it's meant to be rigid. It's rigid because it has kind of an I-beam construction on the top, which gives it structure, and it also gives it a connecting point. It allows us an easy way to connect it to chains. We can screw it off to things. It allows us to connect pieces together, making it very easy. So if you look, we've got different ways we can orient this stuff. It can be used somewhat for distribution plumbing, but we typically are going to use this for a line of irrigation over a bench. We're going to use it as we've actually used it. The larger stuff we can use and support baskets at a 12-inch or 12-inch space without any other support. This would be the irrigation line and the support for the baskets. It looks real nice in a retail setting, maybe, so you don't have to wire tie polyethylene tubing to the outside of a purlin pipe. But the idea is to make it straight, make it rigid. And support is important because we're spending a lot of time trying to figure out, I want this nozzle to be at 3 feet above my crop, and I want it to be at the same height as the one next to it so that I get even coverage as I go down my bench. If I sag by 6 inches at the middle of a run, that changes the coverage. It changes the way that the system works. So support, in addition to looking better, is important to the way that the system's going to work. Now, one of the things that when we talk about support too, we also look at where you're going to put your structure, where you're going to put your irrigation lines. One of the things that we do with this Polyrail is we actually sometimes will mount it directly to the bench. We can mount it at 12-foot sections using a riser system that we've devised, and we generally are going to use this in situations most commonly when we're doing propagation on rolling benches, which is a fairly common thing. People are trying to maximize the space utilization in a propagation area. It's generally a more expensive square foot build, and so you want to maximize that space. One of the things we do not like, though, is if you're using a misting system over, misting is high value crop underneath. You got a lot of density, a lot of plant density underneath it, and we want to try and get the best, most even growth we can out of that space. If we're supporting irrigation lines from the structure instead of from the bench, if the benches move, the nozzles don't stay with the plant. Most nozzles are meant to have an optimal area of coverage, and so centering that on the bench and making that work with the bench is ideal. If we have it just hanging from the structure and we move the bench, those systems are designed really well to be single line accurate. They're not always as great when you put a line next to a line next to a line. The areas of midpoint between those lines aren't always going to be as nice of a coverage as you would as if you optimized it for the space. So something like this, we prefer, whether you're going to use something like our Polyrail system, whether you're going to put PVC risers sticking up out of the bench, no matter how you do it, propagation system we always find works better when we can actually marry the irrigation and the mist to the plants so that as they move, the misting moves with them. Okay, so we've gotten past the idea of what we want to put together. We're putting the system in place. As I said before, PVC is pretty standard. We're using PVC. We don't have to sweat copper. Makes it a lot easier for the installation. That said, we see a lot of hacksaws in the industry. We see a lot of people maybe not doing certain things they should. PVC is a very easy thing to use, but there's a couple things that can make it last a lot longer and better in your facilities. Number one, go invest. If you've got a greenhouse and you're installing irrigation systems, go get a good PVC cutting tool. I personally like ratchet and cutters. Basically, it's a big blade. You've got, certain widths they work up to. You get a nice clean cut. It ratchets, so it allows you to keep putting pressure on the PVC as you cut. There's also the wheeled cutters where basically you just spin them around the pipe and they tighten as they go, so that what ends up happening is they're slowly cutting around the outside until they finally break through. The advantage of these things is, number one, you get a very straight cut. You don't get an angled cut. You don't get rough edges of the cut, and making it a little bit, utilizing PVC better, but making it so that it's a cleaner cut. It's going to fit better into the fittings. Secondly, though, you don't get all the shavings with this. Shavings are kind of the bane. It's one of the reasons we put the filters in. You're designing an irrigation system. You set it up. You just built it all, and then the next couple of days you end up cleaning out junk, and a lot of that's PVC shavings that are just left in the pipe. So something like this prevents a lot of that. The next tool you see there, that little blue piece, that's a chamfering tool. And again, one of the things we see not often utilized in our industry is chamfering. Chamfering basically takes the edge off of the PVC on the outside, helps remove any burrs or any shavings that you might have left over. But more importantly, what it's doing is it's beveling the outside edge of the PVC. And the idea behind that is, as we put PVC cement onto the inside of a joint, if I've got a nice sharp edge, I'm going to scrape a lot of that cement down into the fitting and not leave it on the surface where I want it. I really want it on the surface so that it will bond. What I'm doing is melting the plastic and kind of bonding it together. I want it to happen evenly across that entire surface. Chamfering tool helps us do that. And then finally, the little can you see there, I know a lot of people don't like this because it's purple. What I see when I walk into somebody's greenhouse and I see a bunch of purple joints, is I know that they've done the right job. You need to understand that cleaner and primer are not the same thing. PVC cleaner is meant to clean the surface, meant to take any debris away, meant to take any of the dirt and grime, because these pipes have been sitting in some yard since the day it was extruded. It's been on trucks. It's been moved out in the rain. It's been moved in the dirt. It's meant to clean the surface and get it ready. Primer is actually going to set the plastic up to be cemented. It's a different chemical. If you're not using this, what can end up happening over time is the joints can start to fail a lot easier. The cement doesn't take as well. So using something like a primer, you don't have to buy purple. They do make color. They do make clear primer. But primer is going to make a much better bond, which is going to lead to a much better system. You're not going to have leaks at the joints, 3-4 years down the road, which is when we start to see that stuff. So consider those tools as you're putting your systems together. Now, I mentioned we were going to get into control, and probably the most common thing people are using for control is a valve. In fact, that's the basis of anything. We've got different valves depending on how they're actuated. You've got a hand valve like this, where someone's going to come up and turn it on. That's the simplest way to do it. It's real easy. If I've got a bunch of plants I've got baskets and I want to drip water into them for 15 minutes, I come up, I turn this thing on, I wait 15 minutes and come back and turn it off. The problem with that is I got to remember to come back and turn it off, especially if I got like 10 zones. So how long is that going to, you turn it on, you go get caught up doing something else in the greenhouse. You tend to forget, maybe you've overwatered the plants. At the worst case, it's a bunch of labor. Someone's sitting there having to pay attention to this. We are big proponents of putting control in. However, that said, we have our own line of controllers that we have, for people to use. That said, we are more proponents of using, if you've got a climate control system in your greenhouse, we prefer you use that, because those things have some advanced features that we can't match, and we don't want to match. We're not going to try and emulate what they're doing. They're measuring your climate. They can work off of vapor pressure deficit. They can work off of light. They can work off of conditions that we aren't going to be controlling on. So as you get a little bit more advanced, using things like light, VPD, to help control and regulate how much water and when you water is a good idea. If you're not going to do that, or you don't have a climate control computer, we have controls that are fairly simple in design. They're mainly time-based controls. We do have some nicer features to them, and we would install those, or we would include those in systems, after a conversation about how you want to control this. One of the biggest things, though, one of the biggest challenges we have is trying to get someone from this guy, okay, the standard single hand valve, over to this guy. There's not a lot of money. I mean, yeah, okay, this is a $20 part. You want to put a solenoid valve, it's going to be more money. The controllers aren't all that expensive. $300 for 15 outputs isn't all that much money. One of the things that we recommend to growers, a lot of growers we get on the control side of things, the reason that they don't want to trust a controller is because they want to make the decision. They want to look at the day, they want to look at the temperature, the humidity, is it cloudy, is it sunny, and say, you know what, I need a little more water today, or I need a little less water today, or I'm not going to water today. They don't want a clock making that decision, and I get that. That's one of the reasons we recommend using your climate control computer to make some of those decisions. But one of the things that's nice about the systems that we sell, something like this little Rain Pro controller, we recommend putting this thing in, even if you're planning on going and manually turning it on most of the time. I'm going to go in and turn on a valve. Remember what I was talking about, where you've got that hand valve, you got to go turn it on for 15 minutes, you got to remember to come back and turn it off. We set up something like this Rain Pro, and there's two real nice features about this. Number one is we can set up every valve to run for a specific amount of time. So we got the run that it's going to be impatiens, and I got the run that's going to be begonias, and I might want a little bit, and one's in 10-inch pots and one's in in 12-inch baskets, and there's going to be a different amount of water for each of those. So I've got them set up, and one valve's going to run for 15 minutes, one's going to run for 18 minutes, and that's going to be the standard average based on a normal day. I don't have to assign a start time to that. I can assign that to a program, and I can say all of my baskets are on program A. And I don't set any start times for program A, but I can go manually start program A, meaning that I can walk into the greenhouse and say, you know what, I think it's time to water these plants. And I can go up to this controller, put it on manual, program A, press start, and it will run through all the valves on that program so that I don't have to go back to each valve once I've turned it on. I don't have to remember to go turn it on, turn it off. It takes away some of that labor that's involved and just runs the full cycle. Now, okay, you're going to say to me, yeah, but what if I want to only run it for 10 minutes because it's cloudy? Or you know what? It's 100 degrees outside and it's been sunny and I'm going to have to water them twice today. Well, one of the nice features, if you look at these two little arrows right here, this is a water budget button. So what's happening is we have, I mentioned that 15 minutes. Say I've got one in there for 10 minutes. The water budget feature allows me to increase or decrease all of the watering time on all my valves by 10% in 10% increments. So it's a hot, sunny day, and the 10 minutes isn't going to be enough. I press that button 3 times. I've got 30% more water on all of my lines. So that 10-minute cycle is now 13 minutes. Conversely, it's a cloudy day. I want to just give them a little shot. I can drop that back, press that down button 5 times, get 50% of the water, so it only runs for 5 minutes. It allows me to have the control without having to actually go manually turn on a valve and manually turn it off and remembering to come back. The other really nice added feature of this is that, parts of the season, you're not there, you don't want to be there on the weekend. You don't want to send somebody in, you're not shipping yet, you don't have customers yet. Why send somebody in there to spend a couple hours watering when you could just have the controller do it for a couple of days a week? It's not that big of a thing to let the controller make that decision. You don't have to have the daily operation be controlled by this. You could set it up so program A runs at Saturday at 10 a.m. and Sunday at 10 a.m. and it uses the standard times in there, but Monday through Friday, you can come up and press the button and make it happen. Not a lot of extra money to do something like that. So, as I said, we'd recommend that you use your climate control computer because there's a lot more advanced features that can be put into that. But if you're not going to do that, let's at least consider putting in some type of control, help you with the weekends, help you with that, 3-4 days when you got the wedding, your cousin's wedding you got to go to and you can't get back to water the plants. It's nice to have the automation even if you're not a big automation fan. So I'm assuming most of the people that are on the webinar today are growers, not plumbers. Probably don't have a lot of plumbers that are on the call. And in most instances, I would bet a lot of you have a plumber, though, would come and install or tell you how to design the plumbing in your house if you build a house. One of the things we figured out a number of years ago, when I started in this industry 24 years ago, I had a hard time selling sprayer carts to some growers because they'd say, well, I got time in the off season and I'm going to go weld my own cart up. We don't do that anymore. There's nobody that wants that anymore. Everybody builds their own, or primarily uses our carts when we build a sprayer cart. They don't take a pump that we built and put it onto a tank that they found, and they're not cobbling things together. One of the things that we're finding now is that growers are thinking the same way from an irrigation standpoint. Dramm started at about 8 or 9 years ago, maybe almost 10 years ago, where we started doing irrigation design at a basic level, not charging for it for the basic level. We do design because what we want is to make sure that all the stuff we just talked about, the different fittings, the different components that need to be put into place are included. We want to put together a system that we know is going to work, so that we've designed the spacing for the nozzles. We've made sure that the flow is going to work for the different drippers that we put into a zone. We've zoned it properly. We've discussed all those things with you to make sure that it's going to be done right. And then what we can do is then finally, the thing that's really nice about it is we can ship you a whole kit full of parts that you don't have to go running off to, oh, you know what, I forgot I wanted to put a valve here. We include all the PVC, the fittings, and everything else that would go on the bench at the drippers. We don't do the plumbing, the laterals and things like that, but we will help you with the sizing of that. The idea, though, is doing a complete design for the grower to say, all right, this is what I need. I need to put together a system that's going to do this. We've changed the conversation from tell me about your jet rain nozzles to I need to mist a 6-foot by 30-foot bench. That's what I want to know when you come to me. Tell me what you want to do, and we'll help you select the right system to do that. We'll help you select the right control scenario. We'll help you select all the components that go into it. We make it fairly easy for you to do that. Certainly, you can always call us. But one of the things that we've done is we've added to our website a very simple form. You fill in some information. You are going to get an email response basically summarizing that information. We're going to get a copy of that. We may contact you to say, hey, I need more information. Often we actually will recommend if you got pictures or something, the email that you got, you can simply reply to that with some photos or a little sketch that you have of what you're thinking, and we can put together a system for you fairly simply, fairly quickly. We've basically developed our own irrigation design tools that make it fairly easy for us to design a system. Now, that said, we can do things always more complex if we need to. But generally what you're going to get from us is something like this. That's going to give you a nice little component setup. It's going to tell you all the parts you need. It's going to tell you your price. It's going to give you a basic schematic showing how the thing's supposed to get put together. And that all is going to ship with the system as well. So you'll get a copy of this drawing, as the stuff shows up at your door. If we need to do more than that, say we need to help you figure out how to actually put the thing together, and it's going to, we might even mark out parts that we might not be selling you, but we can put together some simple drawings like this. So from a simple web form, we can actually go through to a design like this. We generally will consult with you quite a bit, talk to you about how you want to strategize, how you're going to control this, how you're going to manage the zones and things like that. But we can even get to the point now where we start talking about stuff like this. We'll get more into this in the other webinars that we do, but we can design complete water management systems. So your tanks that you're going to hold your storage in, your water storage in, all the filtration. We don't really sell fertigation systems. We don't have our own proprietary. We work with other systems. We sell dosatrons. We sell Anderson injectors. We will incorporate them into a design to make sure that the system all works together. One of the things that we find very regularly is that quite often those things are not designed with thought of what is upstream or downstream from the system. and that's something that we put together into the package. We can go through and help you design your plumbing laterals and layouts inside the facility. Make sure that you want to have an AB clear line at every bench in your greenhouse. We can design it for you. We can ship you all the fittings. You just get the pipe. We put that into an entire strategy to say you're going to need this much water as you grow, and we're going to need to figure out how you're going to get more. But we'll talk more about that on one of the other webinars. With that, I am open to any questions that anybody might have that's on the call.
Okay, great. So we did have a question about how to spell the name of a tool that bevels the cut end of the pipe. And our questioner did find it. He said it was chamfering.
Yep.
So that's CHAMFERING for anyone else who might be curious.
There you go. Yeah.
Okay.
Love Google.
Yeah. Great.
You can buy, $5, something like that. It's a great tool.
Great. Also, how do you determine the available flow rate in a greenhouse?
Okay. I showed that basic chart earlier, which basically gives you a good idea of flow. If you're not sure, open up the pipe and measure what your flow is. Because if you don't, one of the things I mentioned, you have a 3/4 inch pipe that goes into the greenhouse, which should give you about 12 gallons a minute. But I don't know what your well pump is set up to do, and I don't know what the city water coming in is set up to do. And so we don't know I might not know necessarily what size pipes coming in from the city, or how much capacity your pump has or your well has. So not a bad idea to get a bucket, measure for 15 seconds, and get a flow rate, just a general flow rate to measure that. It's an important thing because quite often we see people that have undersized the flow for the system, which then end up starving the system and making it not perform properly.
Great, thanks for that. And another question is, how can a grower submit a request for an irrigation quote?
Well, I showed that web page. The easiest way to get to that is dramm.com/irrigation quote, all one word. Otherwise, our homepage has links to it. It's a fairly easy form to submit. There's a separate form if you want to have one of your distributor reps do it and just take care of all the work for you. They've got their own form that they're supposed to use, and you could just go to your distributor and say, hey, I need a Dramm irrigation system. I want the whole thing put together, and I want I want to mist 5 benches that are 30 feet long by 6 feet wide. They might ask you a couple other questions, but they'll submit that information to us as well, and then you don't have to actually fill the form in. Otherwise, you can always call us, 800-258-0848, and we can basically gather the information right over the phone, whichever method you prefer.
If anyone else has any other questions, they can put them in the questions box. We have one more question here, and that is about zone filters. Are zone filters enough filtration for growers?
Generally, no. We put those in kind of as a last line of defense. They're really good for making sure that something, I've had algae and biofilm growing in my pipes, for 10 years. Some of that stuff's going to start stringing off and flaking off and ending up down in the drippers. That happens when you have PVC sitting in a warm greenhouse full of fertilized water. And PVC, especially when you're using the Schedule 80, is slightly translucent, so you'll get some light transmission in there. That's why we see algae as a constituent of that biofilm. It'll end up in your plants, and it'll end up in your drippers, it'll end up in your nozzles. Something like a little zone filter is really important. The zone filter is meant to protect that kind of stuff. It's not going to protect what's coming out of it's not going to be great for pulling out what's in your pond. It's not going to be great for pulling out, some grit you have coming up in the well. Next month we'll have a webinar that's going to be talking more about total system filtration, types of filters, the importance of auto flushing, making sure that they're constantly cleaning. You don't want to be spending a lot of time doing that. And then the importance of those types of system filters are going to be really important when you have a zone filter. If I'm relying on a little 1-inch 150 mesh filter to deal with gunk I've got coming out of my pond, I'm going to be cleaning it daily. And what's going to end up happening is your guys are going to say, you know what, I'm tired of cleaning that filter every day, and they're going to take the screen out and not tell you, and you're going to get the system full of junk because someone got tired of cleaning those little filters every day. If you're cleaning the filters, that's indicative of another problem, and so you want to take care of it with a better tool, a tool suited better towards that.
Thanks for that, Kurt. We also just got several more questions that have came in, and the first is, where is the distributor irrigation form? Could you please answer that?
Distributor irrigation form, if this is a distributor asking the question, talk to your sales rep for Dramm. They'll point you to the right place. You've got like a password to get into it, but that's it's an easy spot on the website. We can direct you there.
Thanks. Next question is, any rule of thumb for what minimum flow rate is needed per grow area?
Depends on what you're growing. Depends on, you know, that's the first thing we need to look at. Like I said before, if I'm misting plants, I need a lot less water than I need if I'm going to be watering larger containers. It also depends on if I'm going to be using an overhead system versus a drip system. Generally, drip systems are a lot lower flow rate. They take a little bit longer to water the plant, but I don't need as much water to do it per minute. So it's really going to depend on, you know, how much or what you're growing first, and then how much of that there is if you're growing a lot of plants versus little plants. We can very simply sit down through a small conversation and say, okay, what's the plan for this zone? You got so many benches that are going to be set up like this. How many plants per bench? We can very quickly figure out how much water you're going to need. And then we got to look at, do you have that amount of water capable there? And that's how we start to break it down as far as a zone. There's really no optimal amount because it depends on what you're doing in that greenhouse.
Great. Next question, tips for how to best design an irrigation system to reduce biofilm growth for growing leafy greens?
If that's going to be, most of the time, that's going to be a hydroponic system, either an NFT or a deep water culture system. You're going to want to watch probably the second and the last webinar series, because we're going to focus more on recirculation of water in both of those. The idea of, really, you're not really designing an irrigation system as much for those types of systems. We're either running water down a trough or we're circulating water in a bath underneath the plants continuously. We've got some experience in designing, so if it's a bath system, we've got experience in how to reintroduce that water to the bath. As far as a NFT system, that's fairly standard. Most of your cropping systems that are available are going to include that irrigation component where it's going to basically regulate the water. What we would be doing, though, is looking at how we would treat that water. We primarily use ozone as a disinfectant. We would filter heavily to make sure that we're taking out any sediment. We'd use ozone as a disinfectant in that water, which would help us eliminate the biofilm, but it also helps us eliminate some of the pathogens we don't want to be recirculating through there. Problem with a recirculating system like that is if a couple plants get pythium, everything gets pythium because you start spreading it through the water system very quickly. We can eradicate that, or reduce that dramatically with using disinfectants. We primarily, we prefer ozone to the other types because it's very reactive. It's the best product out there for eliminating biofilm specifically. But the thing that we really like about it, especially when we look at like a hydroponic system, is that it reverts back to O2 when it's done. So we're using O3. We're basically manufacturing O3 from the air we breathe, injecting it into the water system, using it to oxidize things in the pipe and in the water. And then once it's done, it reverts back to O2, and it's in solution. So we end up with very high levels of dissolved oxygen as a result. But that's something that we will cover definitely more in the next two webinars.
Great, thank you. And we had a couple questions about misters and drippers. One person asked, how do you suggest cleaning the misters/drippers? And another person asked, are misting nozzles prone to clogging?
Okay, let's take the first one, for the last question first, because it kind of leads to the second. Yes, misters are going to clog. You got a smaller, any type of mister. We're trying to create a finer droplet. That means we're using a smaller hole to do it. And so filtration is very important. Now, a lot of times with mist, we tend to see, especially if you have hard water, just because we're adding fertilizer to the water, we're adding salts to the water already. What you can see is some evaporation of that water at the tip of the nozzle, depending on the design of that nozzle, and you might just get mineral deposits rather, not only things like sediment or algae or biofilm. So it depends on what your problem is, really, as far as how you would want to clean those types of things. Personally, we prefer again, I'm going to go back to what we're going to talk about in another webinar, which is a complete management system. If we were using ozone as an oxidizer, we generally wouldn't build the biofilm up in the first place, and we'd be cleaning the drippers constantly because we'd be oxidizing anything out that was starting to deposit in those. So starting off clean and keeping it clean is probably the best way to keep the system clean. That said, there's a lot of systems out there that have been in existence for a while, and it's not uncommon to use some type of a shock treatment. Basically, you're going to use either an oxidizer, like more commonly any of the hydrogen peroxide products that are in the market, or some of the other products, or some sulfuric acid products that'll do similar things. You're going to fill your line up at a fairly high concentration without plants in the greenhouse, because you're generally using a concentration that's much higher. You're going to let that sit for a little bit, and you're going to open up the ends. Don't try and push it through the drippers. Don't try and push it through the misters. But you open up the ends and try flushing that out. You will generally end up getting a very satisfying bucket of muck at the end of it. As it looks like as some of that stuff starts sloughing off. Misters with calcium or mineral deposits, vinegar or CLR, stuff like that is actually really good. So it depends on what your problem is. Depending on the type of nozzle you have, if you're using something like our Jet Rain, one of the things that's nice is that the check valve and the nozzle itself, what actually makes the mist, are two separate parts. So you could actually leave the check valve in place. You don't have to disassemble the system. Just take the nozzles off very easily. They're all press fit. Stick them in a bucket of vinegar to help dissolve some of those mineral deposits if that's what you see clogging things.
Perfect. We have one last question. What are your thoughts on using reverse osmosis?
RO is a tool that we sell when it's required. In our water treatment part of our business, when we're talking, so the part of our business in Dramm Water, we do sell RO systems. We design them when they're required, though. And typically, when we start discussing water treatment of any kind, the first thing we do is take a water sample. We want to know what the water looks like. And what we very commonly found is that RO is really not required for a lot of greenhouses. There's some segments of the industry which have started to really utilize it almost commonplace. And I think it's a combination of past history and just people selling them that. We've seen that it's not necessarily in all scenarios. When it is, it's going to be because we have way too high of a salt load, or going to have certain minerals or things in there that we need to get rid of. But there may be other ways to do that too, depending on what those are. We also sell softener systems. Ozone is a great tool for removing certain minerals, not a lot, but mainly things like iron and manganese. So we would look at the water makeup before we would determine any treatment course. So that said, one of the things that we don't like about RO, certainly I don't like straight RO. I don't see the need for it in a lot of cases. Some orchid growers prefer it, and we've seen it in some cannabis facilities where they're looking at certain feeds that they want to start fresh with just basically H2O. The problem we see with that, though, is that RO, especially by itself, has no buffering capacity at all. And so we see pH issues in the media very commonly, where the pH will start to creep down very rapidly because you've basically got nothing in there to buffer what you're putting in there. And a lot of times, even the little pH adjusting products aren't enough to do it with all the water. We also see, one of the things that we see, I'll bring in a sprayer manufacturer side of our business. We see issues where people are using straight RO. It's all they got is RO water. They start using that in equipment that has, metal components. Even stainless steel can have problems with RO. RO is the universal, or RO water. H2O alone is a universal solvent. It's really good at dissolving things, which is why if we look at, if everybody on this call, if we took your water samples, every one of them would be different. It's different because all that water is holding different stuff based on the area you live, the mineral makeup of the soil, the mineral makeup of the aquifer, what was in the air when it rained. All that stuff is changing the water chemistry. And all that stuff is in there because it's all soluble in water. RO strips all that out. And some of that there's no need to. A lot of that you can adjust through proper fertilizer choice. Some of it you may need to use acidification to help you with. But straight RO, we see damage to metal components very commonly with overuse. So generally, if you're using RO, we would recommend.
Great. Thanks so much, Kurt. So for anyone who may have missed a few minutes of the webinar, or if you'd like to view it again, we will be sending out an email with a link to a recording of the webinar, and the link will include both audio and PowerPoint. In the same email, we will include registration links to parts 2 and 3 of the Everything Water webinar series. Again, part 2 is filtering your irrigation water to reduce shrink, and that will take place June 12th at 11 a.m. Eastern. And part 3 is complete water treatment considerations for improved profit, and that will take place July 24th at 11 a.m. Eastern. Again, thank you, Kurt and Dramm Corporation, for sharing all the information today, and thank you, everyone, for joining in, and I hope everyone has a great rest of their day.
Thank you very much. Thanks, everybody, for listening.